Now consider a new term called as electric flux density. Okay. Here again we are talking about density. Earlier we have studied about line charge density, that is charge by length, surface charge density, charge by area, volume charge density, charge by volume. Okay. Here also we need to define density for electric flux. This electric flux density is defined with reference to area. Okay. So here the density is nothing but with reference to area. So we can define like this. Electric flux density is nothing but total electric flux by area it is crossing. Okay. So simply electric flux per unit area is called as electric flux density. Okay. So flux is represented with the symbol psi, area is A. Electric flux is measured in coulombs and area is given by meter square. Okay. So units of electric flux density is coulombs per meter square. It is nothing but the flux per unit area or flux crossing unit area. Okay. From this equation, if you observe what is psi here, this becomes a flux density into area. Actually, how do we find the area? If it is a shape of the surface is known to us, then we use the direct formula. And if shape of the area is arbitrary or very random, we need to find the area with the help of surface integral. Okay. So area is given by surface integral, then electric flux density psi is given by the surface integral of d bar dot ds bar. Okay. So very important relation. So this is a relation between electric flux and electric flux density, or flux crossing any surface is given by surface integral of d bar. Okay. Now let us see a question on this one. Here consider this question. Here electric flux density due to a source is given by d bar is equal to 5 rho z cos phi aero cap coulombs per meter square. Okay. Then find the flux crossing the surface rho is equal to 2. Okay. So under rho is equal to 2 surface limits are given. Phi ranges from 0 to pi by 2, z ranges from 0 to 1. Okay. Simply we need to find flux crossing rho is equal to 2 surface. Okay. But flux crossing any surface is given by psi is equal to surface integral of d bar dot ds bar. Okay. So let us find answer for this one. Yeah. So we know that psi is equal to surface integral of d bar dot ds bar is the formula. Here electric flux density d bar is given to us, that is surface integral of 5 rho z into cos phi into aero cap dot ds bar. Actually ds bar is the differential surface element. Okay. We need to write this differential surface element for rho is equal to 2 surface. Okay. Here if you observe this one, surface is explained with these coordinates. Okay. Here can you tell me the surface rho is equal to 2 surface is constructed with which coordinates? You know that any surface is constructed with the 2 coordinates because surface is a 2-dimensional region. Okay. Here the surface is constructed with phi and z, but represented with rho is equal to constant, that is rho is equal to 2. If any surface is constructed with phi and z, then what is the differential surface element? Okay. We know that the phi will produce a differential length rho d phi, z will produce a differential length dz. This multiplication gives us the area of the surface. And what is the direction of the surface? If surface is constructed with the phi and z, then remaining coordinate gives us direction, that is aero cap. So this is the differential surface element. Okay. Then we substitute here. Differential surface element is rho d phi dz aero cap. Yeah. Now we need to evaluate dot product between these two vectors. Okay. How do we evaluate dot product? If vectors are given in Cartesian, then we say multiply x components plus multiply y components plus multiply z components. This is dot product. If vector is given in cylindrical, then multiply rho components plus multiply phi components plus multiply z components in both the vectors, that gives the dot product. Okay. Here vectors are given in cylindrical. So in the first vector, this entire term is multiplied with aero cap. Okay, so these contains rho component. And in the second vector, the entire term is multiplied with the arrow cap. It also contains rho component. Okay, so both the vectors has the same components, that is rho components. Just multiply rho components, that is the dot product. Okay, then the equation will be the surface integral of 5 rho square z cos phi d phi d z. Okay, so now let us evaluate this integration. Here we need to integrate with respect to phi and with respect to z. Separate the integrations with phi and integration with z here. Here phi rho square is a constant. Phi rho square integral cos phi d phi integral z dz. What are the limits of phi? The phi limits 0 to pi by 2. And what are the limits of z? That is 0 to 1. So just evaluate this integration. 5. What is rho? We need to find the flux crossing rho is equal to 2 surface. That means on the entire surface rho coordinate is constant, that is 2. Okay, so rho is 2, that is given in the question, 2 square. So this becomes a integral of cos phi is sin phi with the limit 0 to pi by 2, and integral of z is z square by 2 with limit 0 to 1. Okay, so now evaluate the psi. 5 into 4, here sin pi by 2 minus sin 0, and here 1 square by 2 minus 0 square by 2. Okay, so finally the flux crossing rho is equal to 2 surfaces. This is 20 into 1 into 1 by 2. That is psi is equal to 10 coulombs. So simply the flux crossing the rho is equal to 2 surface is nothing but 10 coulombs. Okay, this is the way how we use this formula. If you know this formula, we can find out the flux crossing any surface S if a flux density is given to us. Okay.